Well, I want to do a reality check because, I think to us that are now really focused on technology, it seems like I've heard this story before, right? I remember even in my academic clinical days where it felt like technology was always the quick answer, and it felt like technology was there was maybe a disconnect between what my problems were or what I think needed to be done, and versus kind of the solutions that were kind of uh, created or offered to us. And I guess at some level, how, Jonathan, do you think about this? Because to do things well in the science space is one thing. To do things well in science, but then also have it be something that actually drives healthcare innovation and practice and translation, it's tricky, right?
Yeah, I mean, as you said, I think one of the core pathologies of big tech is we assume every problem is a technology problem, and that's all it will take to solve the problem. And I think, look, I was trained as a computational biologist, and that sits in the awkward middle between biology and computation. And the thing that we always have to remember, the thing that we were very acutely aware of when we set out, was that we are not the experts. Well, we do have, you as an MD, we have other MDs on the team, we have biologists on the team. But this is a big space, and the only way we're going to have real impact, the only way we're even going to pick the right problems to work on, is if we really partner deeply with providers, with EHR vendors, with scientists, and really understand what's important, and again, get that feedback loop.
Yeah, I think we really need to ground the work that we do in the science itself. We need to understand the broader ecosystem and the broader landscape across healthcare and life sciences so that we can tackle the most important problems, not just the problems that we think are important, because as Jonathan said, we're not the experts in healthcare and life sciences. And that's really the secret sauce. When you have the clinical expertise come together with the technical expertise, that's how you really accelerate healthcare.
When we really launched this mission 7 or 8 years ago, we really came in with the premise of, if we decide to stop, we want to be sure the world cares. And the only way that's going to be true is if we're really deeply embedded with the people that matter, the patients, the providers, and the scientists.
And now it really feels like this collaborative effort, really can help sort of extend that mission, right? I think, Will and Smith, that we definitely feel the passion and the innovation, and we certainly benefit from those collaborations too. But then we have these other partners and even customers, right, that we can start to tap into and have that flywheel keep spinning.
Yeah, and the whole industry is an ecosystem. So we have our own data sets at Microsoft Research that you've trained amazing AI models with, and those are on the catalog. But then you've also partnered with institutions like Providence or Page AI, and those models are in the catalog with their data. And then there are third parties like NVIDIA that have their own specialized proprietary data sets, and their models are there too. So we have this ecosystem of open source models. And maybe, Smith, you want to talk about how developers can actually customize these.
Yeah, as we use the Azure AI Foundry ecosystem, developers can feel at home if they're using the AI Foundry, so they can look at our model cards that we publish as part of the models we publish, understand the use cases of these models, how to quickly bring up these APIs, and look at different use cases of how to apply these, and even fine-tune these models with their own data, right? And then use it for specific tasks that we couldn't have even imagined.
Yeah, it has been interesting to see. We have these healthcare models on the catalog. Again, some that came from research, some that came from third parties and other product developers. And Azure is kind of becoming the home base, I think, for a lot of health and life science developers. They're seeing all the different modalities, all the different capabilities, and then in combination with Azure OpenAI, which, as we know, is incredibly competent in lots of different use cases. How are you looking at the use cases? Like, what are you seeing folks use these models for as they come to the catalog and start sharing their discoveries or products?
Well, the general purpose large language models are amazing for medical general reasoning. So Microsoft Research has shown that they can perform super well on, for example, like the United States medical licensing exam. They can exceed doctor performance if they're just picking between different multiple choice questions. But real medicine, we know, is messier. It doesn't always start with the whole patient context provided as text in the prompt. You have to get the source data, and that raw data is often non-text. The majority of it is non-text, it's things like medical imaging, radiology, pathology, ophthalmology, dermatology. It goes on. And there's then this signal data, lab data. And so all of this diverse data type needs to be processed through specialized models, because much of that data is not available on the public internet. And that's why we're taking this partner approach, first-party and third-party models that can interpret all this kind of data and then connect them ultimately back to these general reasoners to reason over them.